Hi, everyone, and thanks for joining us for today's session, Unlocking AI, Auto Documentation and Debugging for Distributed Systems. I'm Tom Johnson, and I've been working on distributed systems and neural nets for most of my career. These days, AI is everywhere, and depending on who you ask, software developers are already obsolete or it's all hype. But as anyone who's actually used AI tools for more than a few minutes knows, the reality is somewhere in between, especially when you're dealing with modern distributed systems. So today, we're going to dive deep into a few areas. We'll discuss what problems is AI good at solving and where does it fall short. What's actually needed to solve common pain points such as system documentation and debugging. And we'll share our learnings from trying to solve these problems. So let's dive in. Before we get into the AI side of things, a little bit about me. I've been working on distributed systems for the past 2 decades at Citrix and across a mix of startups and scale-ups. And throughout all of that, 2 pain points have followed me throughout my entire career. System documentation and debugging. And if you've worked on any reasonably sized complex distributed systems, you know exactly what I mean. So let me share a few war stories from the trenches. I know you all came here for the AI, but this story starts with some good old documentation and debugging chaos. Let's start with documentation. And I don't just mean commenting your code. I mean the entire constellation of system knowledge and onboard guides and tribal lore buried in Confluence pages or architectural diagrams and API specs. And of course, you also have to have that whiteboard photo with that that optimistic title of final system design. So over the years, as a backend developer and then as a CTO, I've seen every well-intentioned attempt to keep this documentation up to date manually. We embedded technical writers into the team, but that mostly meant that they spent their days chasing devs on Slack. We added write docs as a line item in our sprints, but that simply became a permanent resident of the backlog. We would rotate documentation duty across the team, but that led to a lot of sync meetings where everyone realized that no one really knew the full picture. I found a similar image in a company wiki labeled like latest whiteboard workshop on our system architecture. Needless to say, it just wasn't helpful. And that's the core problem. We're trying to document living, evolving systems using manual tools. It just doesn't scale. It doesn't stay accurate, and it definitely doesn't help during a production incident. My experiences with debugging are equally painful, and it's deeply connected with documentation. When docs are out of date or just missing, it's impossible to understand the system. But debugging adds its own special flavor of chaos. You're handed a vague bug report with no steps to reproduce. You open a bunch of tabs, one for logs, one for traces, one for dependencies, and a few more just because you're hoping you might find something useful. You waste hours grepping through log files. And all of this just to understand the problem, and you haven't even started to fix the bug yet. So the result of inefficient debugging in docs is engineering hours down the drain, tech debt stacking quietly, systems you're afraid to touch. And these challenges weren't just occasional roadblocks. They were recurring issues I saw across every team at every stage of growth. And that's what led me to start Multiplayer. I wanted to build the kind of tools I wish I had when working on distributed systems. Tools that make documentation, debugging, and collaboration easier, faster, and more reliable. We spent the past few years deeply exploring how to automate these processes, including when and where AI can make a real difference. And today I want to walk you through some of the most valuable insights we've learned along the way. So let's start with where AI actually helps when it comes to documentation. Most tools we see today focus on things like auto-commenting code, generating user-facing docs from code or open API specs, creating static architecture diagrams. And this makes a lot of sense because AI shines when tasks are structured, repetitive, and have clear input and output instructions. And if you've used these tools before, you've probably noticed they perform best when the scope is narrow and the rules are well defined. And in that way, AI is a bit like a junior intern. It's fast, helpful, enthusiastic, as long as the instructions are precise and the tasks are not ambiguous. But hand them something vague or too complex and things fall apart pretty quickly. But while AI shows promise, it also has some very real limits when it comes to producing meaningful system documentation. So let's talk about 3 of the big ones. It's not thorough. Good documentation is not just about what the system does, it's about why the system was built the way it was. That includes the architectural decisions you made, the trade-offs you considered, the technical debt you accepted. And these are all things you discuss in design documents, meetings, or Slack threads, not things you'll find in code. And AI can't infer the intent or context that isn't explicitly written down. It also doesn't have a holistic view of your system. It might document one service well, but it won't give you a full picture of how services interact, how data flows, or how components depend on each other, especially in large distributed environments. It's not trustworthy. AI can't verify its own output. Even if you avoid hallucinations, the quality of the output is still directly tied to the quality of the input. And here's what most of us are dealing with in the real world. Legacy systems with spaghetti code, siloed teams, duplicating functionality, missing or inconsistent documentation. And even if your code is pristine, can you really say with confidence that you have a single accurate source of truth for your system architecture? Most teams really can't. Another issue, it's not current. So let's assume you have good output. That's great for today. But the moment someone merges a PR, that static documentation is out of date. Architecture diagrams, already stale. API specs, already changed. And even if you generate a snapshot with AI, it lacks the rich contextual data engineers actually need. Things like request response examples, environment details, or links to design decisions. So the bottom line is AI can help, but it's not a silver bullet. It doesn't understand your entire system, and it won't magically keep everything accurate and up to date over time. If we want documentation that's actually useful, thorough, trustworthy, and up to date, we need to stop thinking of it as a one-off delivery and start thinking of it as a continuous system-aware capability. So here are 3 pillars we found to be essential. Real-time visibility into your complete system. Documentation can't be accurate if it's out of sync with the system it describes. That's why you need a live view of your architecture, not just a static diagram in a wiki. This includes everything from high-level logical architecture, component relationships and service boundaries, API endpoints, request response structures, dependencies and data flows across environments. And here's the good news. Your system most likely already emits this data. Tools like OpenTelemetry, Datadog, and New Relic are collecting traces, logs, and metrics all day, every day. The challenge isn't capturing this data. It's connecting it and visualizing it in a way that makes sense to humans. Second, the context around design decisions. Even perfect visibility isn't enough if you don't understand the why behind what you're seeing. Documentation needs to capture things like architectural trade-offs, assumptions made during design, known limitations and intentionally deferred work, and links to relevant tickets, discussions, or ADRs. This is what helps future engineers or future you to make safe, informed changes without having to hunt down the original author or decipher a cryptic Git history. And third, full team collaboration. So finally, documentation can't live in a silo, and everyone needs to be able to contribute. This includes architects documenting trade-offs and intent, developers updating component details as they ship, QA and DevOps flagging environment-specific behavior, and support teams surfacing feedback and pain points. When documentation is treated like a shared workspace, it becomes a living asset. And that drastically reduces the overhead of onboarding, debugging, and cross-team communication. When we set up to tackle the documentation problem, I knew the biggest challenge wouldn't be which LLM to use, but rather how to gather the right data. So we flipped the problem on its head. Instead of starting with AI, we started with visibility. So let me walk you through our approach. Okay. So first, we focused on surfacing real-time visibility into your system using structured telemetry data. This gives us a source of truth that's accurate and up to date because it's grounded in what your system is doing right now. Next, we built auto-generated architecture diagrams that reflect this live data, not just generated once, but kept in sync as your system evolves. Then we added collaboration tools and notebooks to capture the real human context, why decisions were made, how integrations work, what trade-offs were discussed. And that's the layer of design intent that diagrams and code alone can't show. Okay. So now that we have real-time visibility and system design context, we're finally in place where AI can actually help. We have an AI assistant in development that will be able to answer questions and execute instructions with your system. It will offer tools and agents that make it easy to generate and run code using our notebooks. We use a RAG approach to index and select relevant information based on the questions and instructions in the chat. And we also convert open API specs into tool definitions automatically and make it easy for LLMs to call APIs using MCP. This will make it possible to share system knowledge and enable integrations with simple chat and notebook interfaces, both within multiplayer or in your favorite AI code IDEs or popular chat interfaces. So AI tools can speed up documentation, but they don't solve the whole problem. Developers don't just write code, they design systems, make trade-offs, and work across teams. To actually automate documentation in distributed systems, you need more than smart text generation. You need real-time visibility into how your system actually works, automatic updates, not just one-time generation, a shared source of truth where teams can collaborate and stay aligned. Otherwise, you're just creating stale documentation faster. Okay, let's switch gears and talk about debugging. Today's AI-powered debugging tools can do a lot of useful things. Search massive log files, summarize incident timelines, highlight anomalies or known error patterns, even suggest a probable root cause. And honestly, that's already a big improvement over combing through 5 tools and dozens of Slack threads. These assistants help reduce the mental overhead of connecting low-level signals. But just like with documentation, AI assistants hit a wall when they lack system context. They can't correlate a front-end behavior with back-end events and provide end-to-end traces of what actually happened. Understand how a change in one service affected another, detect architectural drift or regressions over time. So you're left guessing, especially in distributed environments where even small bugs can have a big impact. So when we built Multiplayer's auto documentation feature, we already had visibility into system components, services, APIs, and dependencies. So we asked ourselves, what if we could use this system understanding and connect it to the system performance automatically? So let me jump to the debugger. Okay. So that's how we ended up building deep session replays. So you could get a full picture of what happens in a user session, from UI interactions to deep backend traces, logs, request response data, and system dependencies all in one place. And in development, we have MCP support. So here I'm showing you a cursor. I've run a session before. So I can use my favorite AI code IDE to fix bugs that are captured by our debugger. So I was asking to suggest a fix for the session I just showed you, and actually fix the bug. And here's a reasonable fix for that session that I just captured. Okay, to sum up, AI can absolutely help with debugging, especially when it comes to parsing logs, surfacing anomalies, and summarizing incidents. It's like having a tireless assistant who can scan and highlight patterns faster than any human. But AI alone doesn't give you the full picture. To truly debug distributed systems, you need real-time visibility into the actual flow of data and dependencies, same as with auto documentation. You need end-to-end context from the user action on the front end to what broke on the back end. And you need a unified view so your team isn't stuck copying and pasting between browser tabs. So let's wrap up. Here's what we've learned. AI isn't magic. It's not going to replace engineers anytime soon, but it can absolutely augment them, especially if you feed it the right data, the right context, and pair it with tools that are actually built for how distributed systems work today. Documentation isn't just code comments or static diagrams. It's live system architecture insights, design rationale, and API behavior. And if you want it to be useful, it has to be real-time, collaborative, and embedded into your workflows. And debugging isn't just log parsing, it's understanding the full journey of a request across services. To move fast and fix issues quickly, you need session context, system traces, and architecture awareness. So thanks for being here. Feel free to post any questions in the chat box and I'll answer right away. If today's topics resonated with you, I'd love to keep the conversation going. You can contact me at tom@multiplayer.app or on any one of my social channels. Thanks. So I've got a question for the notes. Does it integrate with Notion or other systems? That's on our product development roadmap. And we want to be able to connect to other systems. We're not looking to replace everything, but through integrations, connect to Confluence, Notion on the documentation side, and other tools, Google Docs, things like that. We'll support other integrations as well. From the telemetry perspective, we focus most on open telemetry. That's the direction things are going, but we can integrate with Datadog, New Relic, and lots of other observability platforms. And another thing to note is through, MCP is a really interesting technology. If you haven't started researching it, you should. It's going to be a nice way for tools that use AI to integrate with other systems, easily. And our notebooks will support not just presenting, information that's in multiplayer through MCP, so you can access it through your favorite chat tools or AI IDEs, but we'll be able to use MCP servers within notebooks and other features inside of multiplayer, to connect all of the dots and do integrations really, really deeply and in interesting ways. Yes, so do we use multiplayer at Multiplayer? Absolutely, we have done that from day one. We have a complex distributed system ourselves and a distributed team, and it's been extremely valuable. I would say, personally, I love the debugger. As a back-end developer for many, many years, I've spent way too much time grepping through logs and trying to find evidence of bugs. And I know my friends in QA, they don't want to write down steps to reproduce and have screenshots, and developers want to try to reproduce those bugs or search for APM data. So the debugger has been kind of a game changer for that. You can just focus on fixing and connecting that to tools like Cursor, where it's just, hey, help me fix the bug in the debugger session that I just recorded, is kind of magical. Yes, we do. So we support gRPC, RESTful APIs, have plans for Thrift and a whole host of other common protocols and projects. The goal is to support them all, not just from a documentation perspective, though that's important. Also inside of our notebooks have API blocks and code blocks. So we suggested as an alternative to Postman. So instead of like onesie twosie trying different API calls, you can have a notebook with multiple calls and code, all executed in a safe environment, generated through AI as well. So you can essentially package and share integrations, not just, so as an alternative to sending that Swagger link with all your APIs, or, you can send notebooks to customers, partners, teammates, or use yourself for common scenarios. So I think that, learning curve, if you're in distributed system, this stuff is easy. This is to make your life easy. So it's pretty straightforward. This service comes out of the pain that I suffered working on distributed systems without great tooling, and I'm sure many of you experience today. A lot of the manual work you have to do to find and fix bugs, to do integrations, to update the documentation. It's a lot of manual work. It's a lot of grunt work. Nobody likes doing it. So we built these tools to help with those problems. So I think it's there's not a big learning curve, and it solves some real pain points. And I think for existing teams, if you have documentation tools that you like, our goal is to force people to change all of their ways. So for example, if you like Confluence, you'll be able to embed much of our documentation that's automatically updated inside of Confluence and other tools. So you can still, if you like going to Confluence, You can have your automatically updated system architecture diagram embedded inside of your, your other tools. So it fits within, the tooling that you may have already. Yes, yeah. So question was, since docs are updated automatically, is there history? Yes. So we use, so this is a real-time multi-user, small M multiplayer application, kind of like Figma, where you see, as a team, you're working together on the same documents. And we use, some technologies to make sure that all of the, we use CRDTs to make sure that the resulting doc across multiple uses is source of truth. We snapshot that at interesting points, just like kind of Google Docs does periodically or with a certain number of changes. And that history can be labeled. So if you want to tag certain things, platform architecture, documents with a version or any kind of label that you want, we store that history. And it's really interesting. That's one of the other benefits, is one of the interesting things about documentation that you don't get from APM tools, which might show you, say, a service map in a point in time. With multiplayer, we save that history so you can see the evolution of your platform over time. You might start in one place, evolve over several years, and it can be helpful to see, what changed over time. Yes, so we already we will be for MCP. MCP is a very interesting protocol. We are embracing it. We have our MCP server in development. We'll be releasing it very shortly. I just demoed it. I can actually, I demoed it, connected with Cursor. So it's integrating directly, and you can connect it with other tools that support MCP as well. So yes, we're providing MCP access to everything that's in multiplayer. But on top of that, with our notebooks, you'll be able to use tools and services that expose through MCP. So you can have these rich integrations in a notebook style interface that call out to MCP servers. And that's going to be, it's going to enable some really interesting scenarios. Yeah, any last questions? All right. Thank you so much for joining. It was a lot of fun. Feel free to reach out to me, Tom at multiplayer.app. Love to chat. Have a great day.